Okay, I'm recording now. This is a screencast of me attempting to solve Quest 7 of the Everybody Codes 2024 event. I've not opened Quest 7 yet. I have no idea what it is. As before, I'll be solving it in Go, so let me go ahead and make the new directory, new folder. Quest 7. Copy, paste, whoops, yes, copy, paste. Okay, and here I'm going to delete most of this code. And I'm just going to start with my part 1 code and make sure it says Q7. Okay. Right, let's look at the problem now. So, Quest 7, not fast but furious. Counting, switching. Action. Chariot races are conducted by groups. All participants move, collecting magical essence from the shore. Each chariot is grouped. Each device. If the last action of the plan has been executed, the race is Each device starts on this about 10. Doing if the current power during an action is 0, test round, you can choose any plan from the provided list. Length of the track is 10 segments. Your task is to determine the ranking of plans. Most essence. First. Next, based on that list. Okay, based on this, calculate the total essence gathered with each plan. Okay, part 1 is annoying but straightforward. That's been the general pattern here. Let us move the okay. Let's just look at Quest 7's input. Okay, so then we have to rank them according to this. Okay, so instead of network, what we will have is we will have, here, yeah, let's also do file list open file. So actually we could just calculate these rates here. So let's just do plan scores is a map from string to int. Okay. So then we have plan name split line 0 total 0 for IDX in range 10. Switch split dests I case equals plus case minus and default log dot fable bad spec okay, that, and then total plus equals power, and then plan scores, plan name equals total, and then what we have is we have for name, oh, actually here, plans dot append then slices dot sort func plans func one string two string. Okay, now what is its problem here? Its problem is that int, and then this can be return plan scores plan 1 minus plan scores plan 2. Okay, and then answer is equal to slices or strings dot join plans. Okay, now I'm gonna actually okay Okay, let's do bytes.new new reader Okay, so this is just me being cautious. Okay. Right, and I was right to be cautious because I thought it might come out backwards. I thought that it might be possible to do this backwards, so minus plan 1. Because the convention on the compare function is sometimes difficult to remember. Okay, so let us then delete or cut. Okay, that. Quacked it like a pro, yay. Just over 10 minutes. Unlike this. S. Does not affect. Forces a device, ignoring the current action. Forces a device. Okay. The first action is executed at the first second after S. At the S segment. Okay. The race is set for 10 loops. Okay. Okay, interesting. Okay, so let me see, what is this? Okay, that's just more of that. But now I have to take into account this racetrack. Okay, so first let's do Okay, let's check. Does golang have any kind of literal strings? Golang multi-line string. Okay, so backticks will let me do a multi-line string. Good. Okay, so that's the racetrack, and Okay. Lines. Strings.split. Racetrack. Okay, and now racetrack flat. Okay, so we start. So first I want to get the racetrack all flat. So I do. So I start out with the top. So I'm going to go the top, the right, the bottom. Remember to do the bottom backwards, and then the left-hand side, going up the left-hand side. So first, to get the racetrack flat, I start with the racetrack. That, and now I guess line racetrack lines, except it's range racetrack lines from 1 to length -1. Okay, racetrack flat plus equals line 1. Okay, and then we have bottom. So what I'm going to have to do is racetrack flat string of actually equals bracket -1 yeah, I didn't think so. Slices dot reverse racetrack B racetrack flat slices string racetrack B. In place. Okay. Racetrack flat, that, and then I have to go up the left-hand side. 4 IDX racetrack line 2 and then we do racetrack flat plus equals racetrack lines IDX bracket 0:1. Then okay, so now we've got a flat racetrack. That was entirely too much. Okay. Actually, Actually, most of the rest of this we will in fact use. Obviously we use part 2. Okay, and then we do that. Okay, so this is and then here. So for loop ID x, 0. Loop IDX is in range 10 for track val range racetrack flat. Oh, actually, we want the S to be, at the first segment after S. So actually, what we want racetrack flat to have the S at the end. So racetrack flat equals racetrack flat from 1 plus S. Okay, just moving that S over to the other side. Okay, and then here we have switch. One split. Okay. Okay, so this will become spec IDX. This is also spec IDX. Except, actually what we have to do is we have to do switch on track val. Okay, can we do like this plus track val? Nope, because track val is a byte or rune. String track val. Okay, so what we want is we want case Okay, so we have copy, paste. Okay, so equals, okay, alter equals does not, okay, so equals equals s, power plus equals 0, plus equals plus s minus plus equals plus plus plus. Yep. Minus 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 minus. Okay, so we have, yeah, all 12 combinations. Okay, okay. I think that, yeah, I don't need loop index. Okay, so, yeah, that should work. We'll find out. Okay, no idea if this is right, but we'll find out. Oh good, I was not looking forward to debugging that if it were wrong. Must make their action plan. Oh good lord. Dual is set for 20. Okay, so two things. Yow. And also yow. Okay, so that's the racetrack. Okay, so first what we have to do is we have to flatten the racetrack. Okay, so first we have to flatten that racetrack. So underscore line in range strings dot split. I may not have enough time to finish this in this session. I may have to pause and go take care of some things and then come back and finish this. so there'll be a jump when I have to pause the camera. But the strings.split, racetrack into lines. Racetrack grid, append, racetrack grid. Okay, so we've got that. Now we have racetrack flat. Okay. How do I want to start this? I want to start this with racetrack flat is empty. I'm going to start at zero comma 1. P R C Okay, now while race, no, not while, Go doesn't have a while, for racetrack grid, bracket, P row, bracket, P call, is not S. Racetrack flat plus equals string of where we are. Then if race track grid of P row, actually, you know what, here, I'm going to do this. I'm going to do racetrack map. Except map isn't going to be that. It's going to be a map from int to map. Oh man. Yeah, I gotta add a type. Pause struct x int y int func here pause add dir pause pause here dot x plus dir dot x here dot y plus dir dot y. Okay. Now okay, so racetrack map map from pause to byte for line row line for call I, comma, byte value range line racetrack map bracket pause row I call I equals byte value. Okay, racetrack flat here is equal to position 0, 1 looking is equal to position 0, 1 for map here is not equal to s map here if map actually what do? We do switch no, if race track map add here looking oh add here looking oh glance is here. Okay, what is your problem here? Fine. Then this is going to be an example of a thing. No, you know what? It's fine. Case here plus equals pause. for glance is not that, and glance is not that, and glance is not that, glance 0, glance 1, okay, we look to the left, we look to the right. Looking dot y negative, looking dot x, and we look to the right. Okay, so that's ahead, one looking to the left, looking to the right. Now, if glance 0 is one of these magic characters, glance 0 minus glance 0 is equals, actually, let me just do it here. If strings dot contains plus minus equals s, strings glance 0, strings glance 0, then here dot okay, I may have to go soon, but anyway, one, glance 2, looking becomes that, and if this is true, then looking becomes that. Okay, and at this point I have to stop, so I will come back to this in, I don't know, some amount of time. Okay, and I am back. So, I don't know if I explained what I was doing here, but I'm flattening out the racetrack, and I'm doing that by basically walking the entire track, and at each spot I look to see if there is a part of the racetrack in the direction that we've been going, and then I look to the left and I look to the right, and there will be racetrack in one of those directions only. So Yeah, the closest they ever get is diagonal here. Anyway, that's what it is. I start here at position with row 0, column 1. So I start at the plus sign going to the right, and so then I'll go plus equals and then done. Anyway, so now that I've got the flat racetrack, I believe that the rest should be just as was done. Oh wait, no. So now that I've got the flat racetrack, what else? What is the input? Yeah, I was going to say, I didn't think that there was any input given how sure you consider all possible plans, but why did they any different winning action plans can you prepare? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so there's really no input to read for part 3. Yeah, there's that, and then yeah, so I don't understand why they had a part 3 input file that had anything in it, but whatever. Okay, so now I need to consider all possible action plans, and for that, what I'm going to do is, okay, so what do we have for action plans? We have pluses, minuses, and equals. Okay, so what I'm going to do is I'm going to say, yeah, action plan okay, so yeah, so we have 5 pluses, 3 minuses, and 3 equals. So okay, so what I'm thinking is that I'm going to develop a function that will take one action plan to the next action plan, and then after I'm done, it will just say empty string. And so then I do for action plan is not empty string, we'll count the action plan, and then we will it will count the action plan, we'll put it into a map. So these are plan results. How many different winning action plans? So plan results, make map. Okay, and these are from scores to list of action plans. Yeah. And what we'll do for each action plan is we will have each action plan we'll have this. Okay, and then instead of this we will have action plan action plan. Okay, so these are okay. So, and then once I'm done with this, oh wait, the dual is set for 2024 loops. So 2024. Oh, up here, racetrack flat needs to have an S added onto it. Yeah, forgot that. So we have 2024 loops, and then when we've gotten there, then we will have a total, and the total, so we'll put plan results at total equals append plan results at total, and here we add action plan, and then action plan equals next action plan. Okay, and I need to write this next action plan string. Okay, actually what I'm going to do is I'm going to change this up. That's going to be my lowest value action plan. Okay, and then here I'm going to do then what I have is I have the maximum. Okay, max total, max total, total. And then what I need is I need print line part 3 plan results max total. Okay, so all I need to do now is implement this. Action plan, next action plan. Okay, so I'm viewing action plans as a string, viewing action plan as a number, sort of, with minus less. So what I'm imagining is that action plan is sort of like a number here, and that we're counting, and like it's like minus represents 0, equals is 1, and pluses are 2s, or something like that. And anyway, the algorithm for increment 1 is you take the lowest value, where you can increment it, and then you take everything else down. Yeah. So what I'm going to do is I'm going to start from the right. I'm going to go for something where I can change, if I imagine that the symbols have this order, I'm going to go and I'm going to try to find the first one where I can change the symbol to something. So the equal sign, that could be changed to a plus. And then I'm going to go to the right and see, after I change this, I change something to a higher value, then I go to the right and find the first thing that I can change to a lower value. Keeping in mind that overall totals I have 3 minuses, 3 equals, and 3 plus signs. And when I change something to a lower value, I change it to the lowest value that I can. So right. Okay, so it's going to be kind of tricky working out what I can do at each spot, but I don't think it's going to be that. I don't think it's going to be that bad. So, okay, so we start from the right. So the index of the thing that we're going to move up okay. Yeah, and how do I determine what I can do? I determine what I can do by what's to the left of it. Right? Correct? Yeah, okay. So the index up, we're going to start at lang action plan -1 for action plan RDX up is greater than 0 and can move up okay, so let me define this function, can move up. Can move up, func, spot int bool, and this is going to be if action plan spot equals plus return false. If action plan spot equals okay, then we got to count the number of pluses to the left. So actually, for either of these, pluses to left. That is the number of times that plus 0 for IDX in range spot if IDX equals plus okay. Then if action span is equal and pluses to left is less than 5, return true. Actually, what do we do here? Actually, what do we... spot minus and pluses to left less than 5 or equals to left less than 3, true, return false. Okay, can move up. And so what do? We do this and we move it down as far as possible. Okay, for IDX up, if otherwise we found a thing to move up, so we'll move it up at that and we'll make it, yeah. And now I need this. Yeah, I really should find a way to do this calculation just once, but I don't have a good way to do that right now. So now, okay, so now we have old char Okay, and now what do we do? So actually, old char, we know what it is. Old char action plan is up. So then we say if action plan okay. Oh wait. If action plan IDX up is equal to equal sign, then new char equals plus. Else if equals to left less than 3, equals else okay, and now we gotta find, occurs to me, we don't care about that. Now we gotta find where the IDX down goes. So, IDX up plus 1. And now all we have to do is for action plan IDX down is not equal to a plus sign, and actually no, to move down all we have to, okay, so I go to the left and I move something up. Oh crud, I can still move stuff down. Oh god, this was supposed to be easy. This algorithm for incrementing, you keep going to the left until you can increment something, and then you do the increment, and you go to the right until you can decrement something, and you do the decrement. Okay. What if I call this action. Case minus okay, now okay, and then when we're all done, we'll do new for should be case 0 plus equals case 1 yeah. And then new AP. Okay, so then here what we do is we spot int okay, basically if you have 3 ones to the left of you, you can't be a 1 if you have, oh wait, actually here, possibilities, func from spot int to int. Okay. To left 0 to make map int for v range action IA bracket colon spot gots v then what we have is we have if gots of 0 is less than 3, if gots of 1 is less than 3, gots 2 is less than 5, 2. Okay, now I'm going to say yeah, so I'm going to start again with IDX up, action IA -1 for IDX up greater than 0 and possibilities IDX up has something slices dot contains func slice. This will be func x int x greater than for IDX up, and we don't have something in possibilities that is bigger than okay, so 0, and there's not something that is bigger than what we have, then we do IDX up minus minus. Then what we do, if IDX up less than 0, we just bail. Otherwise, for IDX up plus 1, IDX less than lang, action IA, IDX plus plus, action IA bracket IDX slices dot min possibilities IDX. Okay, I believe That should do it. Oh, wait. Possibilities. Then we also have to change the one at IDX up. So then, action IA at IDX up equals, actually, so what I want is I want the smallest thing in possibilities that is larger than action IA. Slices, smallest thing in possibilities. Okay, so what I want is I want what I want is I want slices.where. You know, I want something out of C#. I want the possibilities of IDX up, and then I want action IA bracket IDX up. Okay, so I know right now that there is something in I know right now that at IDX up I can go up. There is something to go up to. For contains okay, no, that's okay, and then this should do it. This should get me through every possibility. Yeah. Screw it. Let's just run it. Okay, I have a feeling that next action plan is not actually doing what it should. So let's do G So it does seem to be, actually it does seem to be doing what it should. There are just a lot of possibilities. So maybe just grinding through them is not, It's not the smartest approach. So, what else could we... Yeah. See, I'm grinding through all the possibilities, but that's not... This is clearly nowhere near fast enough. So... I wonder if there's a way to discover that we are repeating the same track some number of times. Yeah. So I'm going to let that run for a while. So what if we... Okay, so... Yeah. So I make the racetrack flat. And this is what I do for... Yeah, and the track is... Yeah. Well, it's actually kind of close to getting a plus at the top. I mean, it'll still need to, yeah, it still needs to grind through a lot of these. Kind of wish I were running it in some kind of debugger so that I could just pause it and say, hey, what's the top thing? How many do we have? Okay, now we have pluses at the top. And in theory, once it gets all the way here, it'll stop. God, I don't like this. I don't like how long this is taking. There's gotta be something I could do. Although at this point I might as well let it finish. I mean, yeah, I wonder if is there any pattern to stuff that ends up at the top? Well, I got plus equals as the first two things. Okay. And then, well, I mean, we've got plus equals minus as the first three, so now we have plus equals equals as the first three. Then we'll have plus equals plus as the first three, eventually. And then we'll have plus plus as the first three, and that'll go on from there. Yeah, now we have plus equals plus as the first three. Okay, come on. Okay, now we have plus plus as the first two. So we've still got a long ways to go till we get to plus plus equals as the first three. But once we do, hopefully this will be not that long. Wonder if there's a much faster way to work out action plan. I don't like the way I'm doing it, but come on, get to plus 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 as the first three, because then it's very short. Well, this is really boring, just watching the action plan go up, but okay, there, we got plus plus plus. Now we should work through this quickly, right? Yeah. Okay, what? That can't be right. Yeah, I wish I could have. And that just took way too long. I mean, I'll put it in because your answer is too short. Okay, so oh! Okay, I have totally misunderstood this problem. Your rival knight declares their strategy first, allowing you to make quick note of it. So that's why we have, okay, so I was misinterpreting this problem. Okay, so we have one plan from a rival knight, and the question is, how many action plans can beat it? Okay, I'm kind of annoyed at this problem for obvious reasons, but okay. So all I need here, I don't need plan results. I don't need max total. I just need win count. Okay, and then here, what I need is I need if total greater than other knight when count plus plus. Okay. There, so he has declared an action plan. Okay, so I'm going to copy that from part 2. Okay, so this is what we did from part 2. Okay, and then okay, now yeah. Okay, so if we have every action plan, oh shoot, I'm gonna have to stop this. Okay, so okay, so here's the thing. Once you go around 11 times, 2024 is a multiple of 11. 2024 is a multiple of 11. Once you go around 11 times, you will sync up. So actually, all you really have to do is go around 11 times. Because 2024 is a multiple of 11. Doesn't matter how long the racetrack is, because once you go around 11 times, you will have synced up. And okay, you just care how many times you beat him. You don't care like what you beat him by. So that should speed things up a little. A little. Okay. Almost 2 hours, but well, 1:40, but still. And of course I had to go do other things, but I wasn't thinking about this problem. Okay, but so what I did there, in case it isn't obvious, I realized. So one of the problems here with part 3 is that you're going around the loop 24 times. what I realized is that if everybody has an action plan of length 11, then every 11 times around the racetrack will start to repeat. Because after 11 times around, you'll have gone a number of steps. That's a multiple of 11. You'll be at the start of the racetrack again, so you're going to repeat. Because 2024 is a multiple of 11, see, if 2024 weren't a multiple of 11, we would have to, in order to kind of jump ahead based on this idea that once you go around 11 times you're done, we would have to then say, okay, so like if they were going around 25 times, which is that 11 plus one more, we'd have to say, okay, so we go around 11 times, then we take what's in 2020, we take however many times 11 goes into 2024, and I'm not going to do the division. Actually, wait, maybe I am. Yeah, 184 times. So we take that 184 times, and then we'd go through one more time at the end again for the one, if we were going around 25 times. But we're going around 24 times, which is a multiple of 11. So I know, since all I care about is counting how many of my action sequences can beat this other knight, all I have to do is just see who wins in that first going around 11 times range. And that's what I did. Okay, so let me clean this up a little bit. Okay, that took way too long. Especially because I got up in my head with ways to get the next action plan. Maybe there's a better way to get the next action plan from previous action plan, but this way works. So this algorithm, again, because I don't know that I explained it well when I was working on it, but the basic idea is actually contained in here. So actually, let me comment this. Main algorithm out okay, so this is a basic, this is an algorithm that is useful anytime you are incrementing something that you can kind of sort of squint and say, hey, this is behaving like a positional number. That is like a number written out the normal way we write out numbers. As digits that have positions, and the positions affect the values of the digits. So what you do, so what this is a way to go from 1 to the thing that is the next higher value. So what you do, first off, is you write a function that tells you these are the possible values that I could take at this position. If you were just incrementing a number, like a decimal number, then the possibilities are always 0 to 9 for the digits in every position. Okay. What we have here with action plan is we have to use 3 of these, and 5 of these. So I translate those into 0, 1, and 2. Just I didn't have to actually do that translation. I could have done this entirely as action IA is a byte array. Actually, you know what? Let's actually do that. Let's change that. Let's do here. Translate in action IA is a byte, a slice of bytes of action plan. And then the possibilities are mapped from byte to int. And then I say if gots of minus greater than 3, pen retval minus, retval is also a byte slice. So what I'm doing is, these are the possibilities at a particular spot based on what is to the left of the spot. Okay, now so here's my problem. I do want to compare them minus, plus, and equals, but if I compare them as bytes, I don't know what's going to happen. So hold on, I gotta use Python here. Minus is okay. Okay, so is plus less than equal. Okay, so if I compare them as bytes, we have plus is less than minus, which is less than equal sign. Correct? That is correct. Okay, so if I'm going to compare them as bytes here, I'm going to compare them as bytes, then this changes what the initial value is. So the initial value for this algorithm has to be the lowest possible value. So the lowest possible value is going to have all of the pluses first, then all the minuses, then all the equal signs. So okay. Except here. Pluses less than, minuses less than equals. Okay, so contains this. This is byte. Okay. This is a little bit slower here, possibly, but not really. Okay, and then translate out is just going to be return string action IA. Okay, so action IA is a bad name here for this. I'm going to call this action plan BS, byte slice, and SB, slice of bytes. Action plan as a slice of bytes. So action plan slice of bytes, do that. So the reason I had to get this order correct is because I'm using this order down here. Okay, right. So anyway, back to the algorithm. So I do this just so that I can have something where I can manipulate individual characters of action plan, because you can't really do that with a string. With a string, it's kind of clumsy. You've got to like slice it and put the character in the middle, and yeah. So this is just done because I know I'm going to have the same number of things when I'm done, and I just want to be able to manipulate them one at a time. So then possibilities. So these this is possible values at spot given what's to the left of spot. Okay, so we do that. And then the main algorithm, we start at the far right end, and we start there, and then we keep going to the left until we find something, some spot where we can increment, where we can move the value up by 1, or by 1. Move the value up at all. So, yeah, while we have stuff and we don't have the possibility of increasing the value at this spot, keep going down. If we get all the way past the bottom, then we're done. Otherwise, increment the spot we found the bare minimum to make it one of our possible values. And then from everything from just above what we found all the way down, we make it the minimum possible value. Okay, yeah, so I'm using the native byte ordering here, and I'm using the native byte ordering here, so that's why I had to switch this around to say, no, plus sign is less than minus sign, which is less than equals. And then that means that this is the lowest value possible action plan. Okay, let's just double check that this still works. Yep, still gets the same correct answer. Yeah, and then this, yeah, should have been obvious that they're going for 11, and then 2024 is a multiple of 11. That was a cute trick, guys. Because that makes it so much easier that you can just go around 11 times and you're done. Okay, well, I like this better. I will try to remember this algorithm better. God. So this is a side digression, but funny story. I first saw this kind of algorithm where you're sort of doing something kind of like incrementing a number to get the next possibility in a solution to the problem of finding all open paren, close paren pairs that are balanced. The guy who did it had a... Let's see, how did he do this? I think he had some way of this was in Perl. It was back in like 2005, maybe 2006. It was in Perl, and so of course it was done through some like horrible abuse of Perl's regex notation. But I saw this algorithm sort of used to enumerate all of the balanced parenthesis expressions starting from that and then going, I think, that's 1, 2, 3, 4, 1, 2, 3, 4, 5, that through 1, and you can see, if you compare these where right paren is greater than left paren, that if you consider this as a number where right paren is greater than left paren, then obviously this is the largest number you can have with 10 characters if you're where every parenthesis is balanced and stuff, and this is the smallest one. But but again, it's a matter of okay, so you find the leftmost thing that you can flip. The left, you find the, so you find, in this case, you find the first left paren that you can turn around, and that's that one. Okay, and then, so you turn that thing around, and then you go after that and you say, okay, what can I make this right paren be a left paren? So you start with you end up starting with this, and then the next thing is flipping that around, and then the next thing after that next thing after that, wait, that's too many. So you start with that, and then you go to that, and then you go to, then you say, well, okay, so I could just flip that one around, and then that. Oop. And then you flip that one around. and put into that. Anyway, in any case, it's the same sort of algorithm that I used here to find the next action plan. But yeah, as I said, he used some horrible abuse of Perl regex, and I should look that guy up again. He's about my age, and he's in the Philadelphia area, or at least he was. Anyway, this has been entirely too long. I will try to do the next quest faster so that I don't end up with 2-hour screencasts. Thank you if you've stayed with me all this time and my weird reminiscing of where I first saw an algorithm vaguely like this.